Hello students, welcome to the Old Time Biometry Show. Today I'm going to show you how to do multiple regression. And so here's the example. Peter went out and took photos of a whole bunch of corals. And then he collected the piece of coral and he laboriously counted the number of algal cells that were in the coral tissue. So here we have the number of cells per, let's say, square centimeter of coral tissue. And then we have the intensity of red, the intensity of green, and the intensity of blue from the photos. So his idea here is that he'll try to come up with a cool equation whereby you can just take pictures of corals and then you can predict the number of cells per square centimeter in those corals. It turns out that the number of cells per square centimeter is log normally distributed, so I've calculated that. And so now I want to see how the intensity of red, green, and blue predicts the log of the number of cells. We go to Analyze, and then it's a regression, and it's a linear regression. It's just that it's a multiple linear regression. The dependent variable is the log of the cells. The independent variables are these three color intensities. And then you have to go over here and kind of fiddle around with the output. I think we want to click on this collinearity diagnostics. So one of the assumptions of multiple regression is that the independent variables are not too correlated with one another. And so we want to see how red, green, and blue are not correlated with one another. And that will be reflected in the tolerances. So let's try that. And then, of course, you could save the unstandardized residuals and so on. But I've actually already studied that, so let's not worry about it. So click OK. And scroll down here. The thing that I want to focus on first is the tolerances. So you can see that some of these tolerances are very small, and that's bad. That means that red, green, and blue are correlated with one another. And so we have to do something to fix that. The thing that I'm going to do is I'm going to delete one of the independent variables and just use two of the independent variables because basically they are redundant. The one that I'm going to delete here is the green one because it has the smallest tolerance and also it's not anywhere near significant. So then I go back up here and go to regression, linear regression, and then we get rid of the green one and rerun it. And now the tolerances are acceptable at 0.2, and we can go ahead and interpret the multiple regression. So we can look at the significance values here. Blue significantly predicts the log of the number of cells. Red doesn't, and you might be tempted to delete the red if it were an ordinary problem. But since we're just trying to do variable substitution, it's fine to leave it in there. The real problem comes where we start looking at the R-squared values. So the R-squared value is 0.18. In other words, only 18% of the variance in the log of the number of cells is explained by these color variables. And so really, Peter's not doing a very good job if he only takes the pictures and doesn't actually count the cells. So that's bad news for him. Good night and good luck.